Here we have the tool connected to the car. The car is not yet started. We have the desired line pressure and actual line pressure mapped up in the single graph. And the desired line pressure is what the PCM wants to see, and the actual line pressure is what the car is able to provide. In idle it says 930, and what it can provide is around 660, which is quite low. Let's put it in reverse. It's able to slightly improve that, but the requirement for reverse falls below to 750, which is able to meet. And let's put it in accelerator. Still there. Now let's put it in drive and see how it goes. Putting back to neutral, the requirement came back to 930, which it's unable to support. Let's put it in drive, and now the requirement is still, it fell down to 413, which it is able to meet. So the requirement, anything about I think above 600, it struggles with it.
Before we diagnose what P0868 our current situation is and why are we here, I'd like to go through some of these codes which are part of the line pressure. Whenever we had any line pressure related issues, you might see some of these codes popping up. So the first one is 0868, which is the line pressure low code. Then we have 869, which is for line pressure high. Then we have 932, 934, 935, and 1745. We've already discussed in detail 1745. So 868 is the one. So before I go through these ones, so some of these codes are generic. You might see them in different transmissions. And what we're going to discuss here, some of it may be applicable to a certain transmission, but this one is strictly for 62 TE. So 868 is when if the actual line pressure is more than 5 psi below the line pressure, desired line pressure, while the PC's duty cycle is at or near its minimum value. So this is the pressure control solenoid, and if the duty cycle is low, then it should be it expects a higher pressure, because so first of all, when a solenoid has a low duty cycle, the direct output of the solenoid is high, but that high output controls the eventual line pressure, so that should be low. If it sounds confusing, we'll go through this in detail later on, but for now, just read this line and just keep this in mind, that where the solenoid has is receiving a low duty cycle, then the pressure should be high, and if it's not high, it will trigger up this 868. Similarly, 869, if the line pressure reading is greater than the highest desired line pressure ever used in the current gear, while the pressure control solenoid duty cycle is at or near its maximum value, which results in the minimum line pressure, the DCT will set. Similarly, if the actual line pressure reading is more than 25 psi higher than the desired line pressure, but is less than the highest ever used in current gear, then you'll get 932. So 932 is the one that you get when you have a circuit-related issue. So let's just say that the highest pressure ever observed by a PCM in fourth gear is 100 psi. If the PCM records 95 psi in fourth gear, while the desired pressure was 70 psi, 932 will be triggered. So this is just to explain why we have, or how does the PCM decide that this code is going to trigger. So once you understand why the PCM has raised a certain code, it will be easier for you to go through live data and extract the type of information the PCM will see. 934 is when the line pressure sensor voltage is less than 0.35 volts for more than 180 milliseconds. And when the pressure sensor is less than 4.75 for more than, sorry, this should be more than. So when the line pressure sensor voltage is more than 4.75 volts for more than 180 milliseconds, then you get 0935. So this was the point that we was earlier making. When the duty cycle is maximum, solenoid output pressure is maximum, but the line pressure is minimum. So duty cycle is directly related to the solenoid output pressure, but is inversely proportional to the line pressure. So this is exactly what's been discussed in 868 and 869. let's have a look at how this solenoid works in conjunction to provide a certain line pressure. So this is for, again, applicable to 62 TE only, but most of the transmissions, if you see, will see a similar diagram for those for the line pressure control. We have a filter over here. We have an oil pump over here. The oil is extracted by the filter, and a high output pressure is provided in this line. This is directly the valve body. You have a manual valve. The lever shows it's currently in drive mode, and there's a pressure transducer or pressure switch directly connected to that, measuring the line pressure. Then we have pressure regulator valve. This regulates the line pressure. And then we have the line pressure solenoid itself. So we will go into the construction of this line pressure solenoid later on, but it is usually these two openings, the one at the top and one at the side. They receive the same line pressure. So if it is receiving a pressure from here, it has to bleed some of the pressure from the sides to reduce it. And this is what usually it will do. So when the solenoid is energized, the pressure over here will increase in this. So this is the line pressure, as I said over here, that duty cycle is maximum, solenoid output pressure is maximum. So when we have the maximum duty cycle, then there will be no bleeding off by the line pressure, and it means that anything that goes in here will come out from here, so there will be no loss of pressure. So maximum pressure will transfer from here, but this is not the line pressure. Line pressure is the one in red, so it moves around this pressure regulator valve and it changes the pressure. So you will get a lower pressure over here that is measured by the pressure transducers. So the second thing I want to show you guys is that EMCC solenoid. So this is the torque converter clutch solenoid. It works in a similar way to that of line pressure solenoid. In fact, if you can see, they look almost alike. And it also receives one direct line from the manual valve. And then output of this EMCC will go to the TCC switch valve. From there onwards, it will control the output of the TCC switch valve, which will in turn control the pressure for the torque converter clutch engagement. So let's have a look at possible failure points resulting in line pressure related DTCs. The first one and the most important is the clogged transmission fluid filter. So it's almost a given if accompanied with a loss of prime DTC, which is in a P0944. So if you have a line pressure related core and then you have 9044, the first thing they should do is to change the filter. So the filter is clogged, makes sense that the fuel pump is not able to build enough pressure, and that is why the line pressure monitored by the transducers is not sufficient. Electrical issue is another issue. 5-volt supply is missing or degraded, loose connector, ground missing, degraded. So you can check all these things once you have opened up the valve body or the front where the solenoid housing where it has the solenoids in it. You can measure these things. Clogged VFS solenoids. So both the pressure solenoid and TCC solenoid, sometimes called EMCC solenoid. These, if they are clogged, then you can expect these line pressure related DTCs. Aged VFS solenoids, even if a VLS VFS pass all checks, it may still be bad or lazy or tired. The reason the reason actually I'm bringing up these VFS solenoids is that these are very, very sensitive solenoids, and they try to maintain a very delicate balance between the ordered and the desired line pressure. And with the passage of time, they can deteriorate. There are a few tests that I will show you how to test them to make sure that they are good enough. But even if it passes all those tests, I would still recommend that you go ahead and change these VFS solenoids, because if they're lazy or tired, you cannot measure it actually. It's not measurable. Only PLCM can measure the impact And plus it has actually a predetermined table that this is the type of duty cycles to which this is the pressure should reflect. But if it's not happening, then it will trigger DTCs. And even though the VFS solenoids are passing all tests, you'll still be banging your head that what's going to happen. So yeah, I would recommend changing VFS solenoids, even if it passes all those tests. Oil pump, a bad oil pump will be unable to provide the desired line pressure. Makes sense. And this thing is very, very rare, I would say. So we can actually do a free pre-test to make sure that to actually narrow down on some of these causes before we started working on the ground. Internal transmission unknown problem. When all fails, it points to internal problems, so the possibility is rebuild or replace. So the only thing that I can think of internally that can fail is the oil pump, or maybe somebody has rebuilt the transmission recently and didn't put the correct, I don't know, maybe seal or valve somewhere, or some of the items are incorrectly assembled. That happens all the time. So before we try to fix, we need to get the answer to a couple of questions. First of all, is pump able to deliver high pressure? For example, in my case, as you've seen in the previous videos, the pump was able to provide pressure up to 750 kPa, right? So even if it was able to provide that much, but during the drive cycle, it wasn't delivering that sort of pressure. It was going to 430, 450 in neutral and reverse, especially neutral and park, was very much low. I mean, about 25 psi lower. So that tells me that my pump is able to deliver the high pressure, because when I switch around, I can see that there are pressures, spikes of pressures, steady spikes, not steady spikes, steady high pressure graphs. I can see that. But under certain gears and conditions, it's not doing that. So it means that my pump is fine. So this is what you want to figure out before you start working on the car. So if the answer, if you get to the answer to the question, if it's no, then maybe a clogged filter or bad oil pump, right? Because yeah, if the filter is clogged, the pump is bad, you will not get high enough pressure. But if you witness high line pressure, it may not be the pump. High line pressure in certain cases, that's earlier, like if it's able to deliver about I don't know, maybe 700, more than 700, while your low pressure DTC comes up at when it is failing to meet to 600 maybe or 500. So it's all relative. You have to really think down on what you're looking at. Do you have a fixed value against the line pressure signal value PID, like 4 volts or 1 volt, and it's not changing or changes erratic? So you have a PID which you can go on the live data and see over there. If it's static and there is not changing, then it means that definitely there's a problem with the line pressure sensor. It's really, I would say that it's really improbable. The line pressure sensor is bad. It can deteriorate with the passage of time, for sure. And if you want to do that one, I haven't listed it here, but if you want to change line pressure sensor, before you do that, you should measure manually the line pressure. There's a tap in front of the valve body. Underneath it, underneath the valve body, there's a tap over there. So just put in a manual measurement tool in there and measure it, and measure the value, compare the value of the manual measurement with that of the line pressure sensor, and see that if you're getting the desired result. So if you have a problem with your line pressure sensor, then you'll get a static value, 4 volt, 1 volt, or you'll get a different value if manually measured. Otherwise, your pressure sensor is fine. And as I said earlier, I mean, regardless of what you find, if you are in a situation where you are battling these line pressure related DTC, especially the 868 and 869, I would definitely recommend ordering up the VFS solenoids. You should replace them. They go bad time to time. If they're not already bad, they will be bad soon. So let's have a closer look at the construction of variable force solenoids. So this is just how a variable force solenoid looks like. Both the type of solenoids that we have, the EMCC solenoid, the TCC lockup solenoid, or the line pressure solenoid. Both of them are variable force solenoids. So this is how the outer body looks like. It has three different chambers. The top one is where the line pressure gets from the pump. The middle one is the where it goes to the valve body, and the lowest one is actually a vent. So if you remove the outer shell, you will get something like this on the right. So there is a coil in the middle on this chamber, and then there's a plunger in the middle that goes all the way to the top. And red one, this red rectangle at the top is it's like a top of the plunger which has a steel ball in the middle, and then we have a cavity over here, and this steel ball, once this coil is energized, will go to the top of the cavity, and it will stop the path of fluid that connects between this particular line, this particular cavity, and the one that's shown by the dotted line. I'll show you here in the detail how it looks like on the right. These are the actual parts when dismantled. This is how it looks like. So the outer blue shell is representing this one, which is on the left, this side of the top side of the transmission with three windows, the top, the middle, and the bottom. So the top, middle, and the bottom over here. And it houses these two items. One is this plastic kind of a tower, small, that goes on top of a metallic circular disc. So the metallic circular disc, on top it has a hole, and on the bottom it has these four lines, four pathways for fluid discharge. And if you look at the top of this plastic thingy, there is a small hole in the middle. So when it is placed over here, the fluid has a freeway, and it can access the vent of this solenoid via this pinhole access. So this is usually open. So when you have this solenoid in your hand, you will see that there is an unrestricted access for the fluid or the air to go from all the way here and then vent it out from here. See, for example, it goes from here, goes all the way to the bottom through this hole, and then comes out from here and moves right or left. So there are actually four different paths it can take from the vent, but the solenoid itself is marked with only two. So that two are good enough, you can see. And on this one, there are only two, one and two. Even these two are blocked, but it does not make any difference. And yeah, so the bottom coil will have a plunger like this, and I've lost the steel ball, so I just put a dot in here. So when it is not energized, it looks somewhat like this. And when it is energized, this moves slightly up, and the ball goes to the top and blocks a hole in here, and thus prevents the discharge of fluid coming through that plastic tube from the top. So looking at all this, you can see that these two, based on this description that was set, is that these two chambers, the top one and the middle one, they are ideally and usually are connected without any obstruction in them. So if you blow air from here, it should come out of here without any issues, and it will never be restricted. And I think this is why I say that when the line pressure is sent to the solenoid, it comes out from here entirely to the valve body. So when it comes from the oil pump, all the pressure goes to the valve body. The only time when the PCM wants to prevent is when it will energize the coil, and it will stop this metallic disc from the bottom. Once it is stopped, some of the liquid, I said the other way. So all the pressure that comes from here goes from here, and some of them seeps from here. So when it wants to stop it and wants to increase the output pressure of the solenoid, the PCM will energize the coil. This ball will seal the bottom, and the fluid will no longer be able to escape from here. So all the pressure that will come from the oil pump will then be reversed to the valve body. So once it is doing that, the pressure to the valve body increases, but the overall line pressure decreases, because this pressure is controlling the regulators, the pressure regulator valves and the TCC control valves. So yeah, these two are inversely proportional. So the second point that I would like to make is that have a look at the difference of height between the energized and non-energized conditions of this coil. It's literally 2 or 3 millimeter hardly, but this is all what it takes to control the pressure for the PCM using this sensitive mechanism. I haven't shown a small spring that goes at the bottom between this bottom of the plunger and the casing. There's a small spring. I haven't shown it, but that spring, along with this 2 to 3 millimeter of travel distance, will dictate that you are going to get your desired pressure or not. So this is quite a complex solenoid, quite a complex structure, and this is the reason when I say that even if your solenoid passes all the tests, it may still not be good enough, and you should still be replacing the VFS solenoids to ensure that the fix that you are doing is going to work. So based on all these descriptions and all these symptoms, I think that the two actions that I'm going to do is, first of all, I'll replace my transmission filter, even though I don't doubt it, because I don't have any loss of pressure or 0944 registered, any DTC related to this. Similarly, I can see that my pump is building enough pressure, but while I'm working on the car, it's a good idea to change the filter, so I'm going to do it regardless. And the second thing is I'll take out the VFS solenoids. Both the VFS solenoids, there are two in there. One is for EMCC, and the other one is for line pressure, and I'll try to replace both of them. And EMCC solenoid, I think that I also observed some shuddering when my car was about to come to a stop, which points to a bad EMCC solenoid again. So this one is definitely bad, but line pressure solenoid, since I'm doing that, I will not take the chance and I'll fix that one too. I'll replace both of them. So let's see how it goes.
The trick to put this one in is the there are three different holes in it, slits in fact. So find one of the slit, for example in this case this is the one, and center it so that it goes on the sides of the slit, and then push it slightly and make sure it does not jump anywhere, because it really likes to jump and springs away. So make sure not to lose it. Yeah, now this one's in. See, second one. Find the slit first. There are three slits, so find one of them. That's the one. So we'll go on sides of it and then slightly push it. Yeah, this one's also in. So you'll have to continue removing the stuff out of your way till you have enough clearance. So removing this is not an issue, but putting the sealant on and putting it back, the cover, this is going to be an issue. So that's why you need to make sure that you have plenty of room. So feel free to rearrange the wires, the pipes, and use zip ties or any other things to just make sure that they don't come in your way. So in this test, what I'm going to do is I'm going to provide some voltage to these solenoids that I have removed. And to do that, what I'll do is I'll use the positive terminal, and if I hold it like this, I'm going to provide it to the left side. Okay, so positive terminal goes to the left, negative goes to the right, and I'll try to hear the clicking. There is some sort of clicking I can hear, but it's very inaudible. You have to really pay attention to it. As compared to this, if I take the new one and if I want to try to hear the clicking, negative on the right, positive on the left. A very audible click. So it can be because of two reasons. One may be that this is fatigued and old, not sure. The other one can be, or that it is clogged. So I think I'll have to go ahead, disassemble it, and then I'll see what sort of problem is in there. I also am interested in looking at the internal architecture of these solenoids. Before we do that, let's try the last solenoid that we have. Now this is the line pressure solenoid. So again, we have to go to the left, positive, and right for negative. Yeah, very dim clicking out of it, but it's slightly better than what this one is doing. Just to give you guys a look at the internals of this variable force solenoid. So on the top section, it's like this. So on the outer shell has been removed completely, of course. So on the top section, inside those windows, we have this plastic piece. Underneath it, there is that metallic window, and there's a circular hole in the middle. And between this and the plunger of the solenoid itself, which is at the bottom, there's just a small steel ball, which I lost, unfortunately. And that balls, whenever the plunger pushes the ball, it actually goes through and blocks the fluid coming out. So it works like this, blocks it, and when it de-energizes, go back, the ball goes back, and now the fluid can go through those vents. Let's talk about this line pressure solenoid. So first of all, there is a bit of ambiguity in the name. Sometimes they're called as line pressure solenoids, sometimes they're called as VFS solenoids. The thing about these solenoid is that these two solenoids, these are both line pressure solenoids. And the line pressure, sorry, not line pressure solenoids, they are both variable force solenoids, which means that based on the commanded output from the PCM, they can control the pressure on the line. And I wanted to replace this regardless of whatever the issue is with the transmission, because I have a doubt on this one. When I checked with the dealership and for the aftermarket spot, I couldn't really secure a good alternative for this one. And it comes new in the solenoid packs when it's sold with as a spare part, as a complete assembly, the solenoid pack itself. But that pack was costing around more than $1,000, so I thought probably either I'd go for a refurbished one, or there are a couple of manufacturers in US that make spare these. I think it's called Rosta, and there's another one. So there are two manufacturers that I came across that are selling these, and I think it was $150 or so for me to get it in Australia. In the meanwhile, I realized that this line pressure solenoid and this TCC solenoid, the construction of both these solenoids is extremely same. The electrical properties are the same, the size is same, it's just the shape is a bit different. So you can probably have a look at it and see for yourself that it slightly looks different, but rest of it is same. So even the resistance for both of these is identical. I had a better look at this then and realized that they are the same part. It's just that one of them is given these particular connector shapes and one of them is given this connector shape, and plus a hook on here. So what I'm going to try now is to convert this TCC VFS solenoid into a line pressure solenoid. And the reason for this is that these are accessible, these are available, readily available, and yeah, apart from that, essentially the same part. So let's see how we do it. So the first part would be to remove this thing. Yep, it's removed. Now you can see that it's same. So now I'll remove this part. The plastic has never been good on these solenoids. So yeah, it's breaking easily. So there is a bit of plastic piece that's fell in there. It's not gonna affect the performance of this solenoid, and the reason is that this is the internal part. So what happens is that it's currently this plastic piece is between this coil and the housing, and it's always going to remain here. It's not going to go beneath, it's going to come above, so it's not going to really impact the issue, so I'm just going to ignore it. So now we have almost similar looking solenoids. We just need to put something in here to beef it up. So this is where it needs to go, and I think I can probably use it. It's just that I need to just spread it those legs up a bit. So this is the final product. It may not look beautiful, but I'm pretty sure it's gonna work. This was the original line pressure solenoid. The only difference now is this ring. We have to take it and put it in there. Yeah, there we have a bootleg version of the line pressure solenoid. So let's see, we'll put it in there and see if it works, but so far I'm not really sure that the problem was this line pressure. I do know that the torque converter clutch solenoid VFS, it was bad. For that I have this replacement one, so I'm just gonna put this one as is, but this is the new one that I created. So this is now what I'm getting after restarting the car. I've put everything back in, so now it is right on mark. The desired is 135. I'm getting 131, 132, 135. and if I go to reverse, the desired actually moves around and then falls to 110 and it follows it. Go back to neutral and the desired is 135 and I'm more or less on the mark. It's not an issue. I go to drive, it will momentarily go up and then go down. Yep, it is 60 and I'm back to 60. Let's go back to park. Yep, I'm 130 something.